Hey everyone, my name's Brian. Thanks guys. And I'm a software engineer on the App Engine Python team. 4 months ago, we released the latest App Engine runtime, Python 2.7. And it's already, in the last 4 months, it's now gets 47% more applications than the Python 2.5 runtime, which we released 4 years ago. So this talk is basically about how you get the most of the new Python 2.7 runtime. So I'm kind of targeting this talk for people who know something about Python and know something about App Engine. If you don't know anything about either, this talk is going to completely go over your head. And this is where the people who are watching this on YouTube have the huge advantage. They can just hit the back button and go find something else to do. People here who are sitting in the middle are going to have to use some sort of ninja skills to sneak by people and find a new session without getting in people's way. But I do, even if this talk isn't valuable for you, I actually have like App Engine plushies to give away at the end as some form of bribery. You can't pre-claim them. Be first come, first serve at the end. There's actually more to the Python 2.7 runtime than just Python 2.7 language features, which is actually why it's the second point on the slide, not the first. So I'm going to talk about 4 things. One is our new library support for the Python 2.7. Then I will talk a bit about just language features in Python 2.7 that are useful for web application development. Some of the limitations that we've removed from the Python 2.7 App Engine runtime versus 2.5, and concurrent requests, which is hard to explain in one sentence, but is possibly the most valuable feature that we're adding to the Python 2.7 runtime. So I'm going to start talking about third-party libraries. And I'm just going to leave this slide up for a couple seconds so people read that I designed this part. And then people laughed. I have my acknowledgement, and we can move on. We actually have to start a bit in the past to really understand why this is important. This isn't actually the Big Bang. This is a picture of the simulation of the LHC, Large Hadron Collider, producing Higgs bosons. Because if you remember, this is all what we were doing in 2008. We were basically waiting for the LHC to start and end the entire universe. But the App Engine team actually beat them to the punch, and we released App Engine in April 2008 with Python 2.5 as our launch runtime. So I don't know if you remember kind of what the environment was like in 2008, but it was pretty primitive. There were like Tyrannosaurus rexes chasing Triceratops around. Well, not really, but we had some pretty barbaric software. Django hadn't hit 1.0 yet. It's like the premier Python web framework. WebOb, which is like, probably represents another half of Python web applications are built on top of it. It hadn't hit 1.0 yet. And App Engine kind of evolved. We made our data store much more reliable. We offered an SLA. We went out of preview. But we were kind of stuck using these older libraries for backwards compatibility. We had no real way of upgrading without breaking all of our existing applications. And backwards compatibility is something we take really seriously. It also meant that we couldn't add features to some of our own libraries for the same reason. We couldn't make changes that we wanted to make just because they would have broken people. So the solution for this, well, for the dinosaurs, it was a big comet. And for App Engine, it was the release of the Python 2.7 runtime. This was our launch cake. It was tasty. And let me just jump to the punch here. So in Python 2.7 on App Engine, anyone who's done any App Engine development should recognize this configuration file, or at least the top non-red part. It's basically we're saying, we have an application that I've creatively called my app, and then just some data for it. It handles, every URL pattern with a script called main. And the new part is we have an explicit libraries declaration at the end. So this means my application is dependent on Django, and I really need version 1.2. I'm explicitly depending on version 1.2. So version 1.2 of Django is not the latest version that we support on App Engine. But the person who wrote this application doesn't have to care, because they've explicitly stated this is my dependency, and they can upgrade to a newer version later whenever they feel like it. It's under their control. So this basically solves the problem of us not being able to provide newer software due to reverse compatibility problems. You just explicitly state what third-party modules you're dependent on. So let me make this more concrete by showing you like a real Hello World web application. So this is pulled out of the tutorial for Python 2.5. So you can see we start by importing a very simple framework that we wrote called web app. And this is actually the framework I was saying that we couldn't upgrade, or we had problems upgrading for backwards compatibility reason. We define a very simple handler that in response to GET requests just outputs hello world. We make an application object. We define a main function that runs the application object, and then we do the standard Python if name equals main, run the main function. Simple, and a lot of this is boilerplate. So if you look at the Python, right. So I have a terrible memory, so I have audience plants to remind me of things. So the reminder here was this code will work absolutely fine in the Python 2.7 runtime. You can just take this Python 2.5 application, and it'll run perfectly in 2.7. But this is, if you were writing new code, here was how you would write it idiomatically in Python 2.7. So you can see I've replaced the import of web app with web app 2. So web app 2 is an open source, a lightweight web framework that was strongly inspired by Google's web app framework. But the fact that it's versioned like the other third-party, like I showed you before, so that means it doesn't have to be strictly compatible with releases. You can say, I am dependent on an exact version. So in fact, it's so compatible that the only thing I had to change to make the example work is I changed web app to web app 2 everywhere. And you also might have noticed that the example is a bit smaller. That's because all of the boilerplate that came at the end is no longer necessary in the App Engine Python 2.7 runtime. This is because Python 2.7 can natively speak WSGI, also called WSGI, while the Python 2.5 runtime could only use CGI. So if you don't know what any of those mean, it doesn't really matter. Think of it this way: 5 lines of boilerplate are gone. Yay! And here's what the configuration would look for Python 2.5. I've defined my application. Version 1, I'm using Python. The first start is completely standard. It'll be in every application. In the end, I say every URL should be handled by my hello world script. And in 2.7, looks very similar. The runtime is changed from Python to Python 2.7. I have to add this explicit thread safety declaration. Right now, I'm just setting it to false, which is kind of the safe option. And I'll talk a lot about how you can set that to true at the end of the talk. The handler, the script changed from hello.py to helloworld.py to helloworld.app. I'll talk about why you make that change later as well. And finally, I say I'm dependent on the third-party library web app 2, and I want to use the latest version, which is 2.5.1. Okay, but no one is going to make $1 billion with creating a Hello World application. So this is my Google Plus, some photos. Here's me hiking with some friends, holding a big rock. And yeah, it's interesting. And here's, this is an App Engine application I I wrote, and I just pasted the URL for that picture at the end. And here's a picture of me hiking with friends as viewed by the predator 2 seconds before it kills us all. Has everyone seen the movie Predator? Oh, not everyone has their hand up. It had great one-liners like, "Get to the chopper," and "If it bleeds, we can kill it." So anyway, I'm thinking about calling my new startup Predagram. I think we can probably flip it for about $1 billion in a year or so. And so if you have like maybe $50 million of VC money, give me a call. And unlike most developers, I will show you the code for our startup before you even have to invest. But looking at the code does commit you to investing. So leave the room if you're, whatever. So if you look at the first line of this example, this is a complete example, by the way, the entire application, 21 lines of code that you can kind of see I squash the imports together. So the first line is just imports of core Python libraries. And it's the next line that's actually a bit more interesting. I'm importing NumPy, which is a Python numeric library, and PIL, which is an imaging library. So NumPy was the third most requested third-party library for App Engine, and PIL was the #1. So both of those are now supported in Python 2.7. And I'm not going to go into too much detail about how you would actually do this kind of image transformation. The basic idea is I don't care what the original colors in the image are. I'm going to replace them by my own color palette, which I defined in the beginning. I'm using NumPy in a very trivial way. When I write for H in NumPy lin space, that's basically I want a linear interpolation between 0 and 1 in 256 steps. So I build a 256 color palette. And then if you look in the get handler for the request, I take a URL, which is all the stuff that comes after image in the URL scheme. I load it using the Python URL lib. I open the image I've downloaded, convert it into grayscale, replace the palette, convert it into PNG, and output it. And that's 21 lines of code can be yours for $50 million. And the configuration, this is what the configuration looks like. It's similar. It's basically the same as what we saw before. The same initial 5 lines to define the application. Now I'm handling image slash in my image space. My script name changed a bit. And I'm dependent on NumPy, PIL, and I'm still using WebApp 2. OK, so those are kind of some neat libraries I touched on. And WebApp 2 is useful, but less neat. Here is the full set of third-party libraries that we support explicitly in the Python 2.7 runtime. I'm not going to talk about them all, but I'll point out a few others. So Jinja 2 is a templating library. In the Python 2.7 runtime, we had our own simple templating system called webapp.template, which was a very simple facade over Django. And our use of Django was kind of sketchy. It wasn't thread safe. It had some problems. So we're actually recommending people who like Django templates and Django configuration to just use Django templates directly. And if they want a very compatible solution without having to do Django configuration, just use Jinja 2. LXML I should probably mention because it was the second most requested third-party library for App Engine Python. I only didn't create a demo for it because it's very hard to make an interesting demo that involves XML parsing. But please contact me if you can think of a way. And then the rest is just, there's more, but I'm not going to get into them all. So I will mention that this is early days. We released this runtime 4 months ago. So this is the set of this is the set 4 months after release. This list will grow over time, or you can expect it to grow over time. And we are responsive to people filing feature requests on our external issue tracker. So you can see we packaged like the first most requested module, the second most requested module. The third requested module, you can kind of see there's probably a pattern here. Yeah, I think that's it. Move to the, sorry? Right. See, audience plants, very important. So also mention that there's like these are the libraries that we provide explicit support for you. You know, Python says it's kind of a batteries included language. We throw in some more batteries that are included to make it easier to do web development. But if there's another battery you want, like your own web application framework, like Flask or Bottle or whatever, then it's no problem. You just download that yourself, and it'll get uploaded with your application. Thank you, audience plant. Okay, cool. This is my favorite section. This is, you know, there are things in Python 2.7 itself that are new, that are useful for web development. And the great thing about this is basically I can take credit for work that other people did. More demo. So this is my value add. Having a billion-dollar company is cool, but I want a bit more. So I think this makes our company worth $1.5 billion. So before I had to paste a URL and it would generate the predator view of the image, now I want to do so I can just take Google Plus IDs and go to this different application called Predator Plus and just paste the ID here. And it'll show your Google Plus profile you know, using Predator Vision. So I think this will allow us to make our own Google Plus clone that provides the high contrast colors that the discriminating predator wants, and we can completely corner the extraterrestrial market for Google Plus, or at least homicidal extraterrestrials. Anyway, value add, call me, $50 million gets you in. So here's the app that adds that little feature. Google Plus has a JSON API, or sorry, it has a high-level Python API, and also just a JSON RESTful API. I'm using the JSON API because basically my example would suck if I didn't, because I'm trying to demonstrate JSON. So you access this profile URL, filling in, you can see I have user ID there. You fill in the user ID with the user's actual ID, that number you saw. And then let's look at the actual code. So in my GET request, I'm now interpreting, instead of taking a URL, I'm interpreting it as a user ID. I'm going to, if we read this code from kind of the inside out, I'm taking the profile URL and formatting it using the passed-in user ID. So format is a feature that wasn't available in Python 2.5. The next thing I'm doing is I'm using URL open to load the Google Plus profile. So there's timeout argument is now available in Python 2.7 for URL open. And this seems like a really small thing, but it's actually a huge thing for web application development. If you are using like a Twitter API or Facebook or whatever, you're interacting with any other service when you're building your web application, it kind of sucks if like it's taking them 10 seconds to handle requests if you're blocked for those 10 seconds waiting for them to come up with an answer. It's probably preferable to say, look, I'll wait, you know, in this case, 200 milliseconds, and if I don't get an answer from them, then I'll just serve some sort of degraded response. Well, in this particular case, it's very degraded. I redirect them to a static image, but you know, you can probably do something smarter than that. So I'm using this timeout thing, and finally I'm using this new C-implemented JSON module that's available in Python 2.7 that parses the Google Plus profile. The rest of the code, it's not. By the way, this is a programming demo hat trick. 3 new features in 3 lines of code, and they're consecutive lines of code, so it's actually a natural hat trick. No one cares about hockey, and anyway. Thank you. So finally, down here you can see I build the URL just by extracting the image from this. I've got a Python profile as a Python dictionary now. I look up the image key, the URL key. I split off all these query arguments that I don't care about, and I've got a URL, and then I just proceed like you saw in the previous example. There's good docs for the Google Plus API if you're interested in how you would do something like this yourself. Okay. Kind of hurt, actually. You all laughed at my VC thing, but no one actually offered money. So I'm going to go into banking, because banking's where the money's at. Sorry, that was bad. But I'm going to highlight a few little things here. This is, I'm trying to model a banking account system here. You can see the first thing that's kind of new, like in the last couple months new, is I'm using a new module called NDB. So NDB is the new next generation Python database framework, data store framework. It has some great features that are really hard to see, so I'll just tell you about them. So one feature is it does implicit caching. So when you're creating items or looking them up, it'll cache them locally in local memory. It has another level of caching where it will use memcache, and then finally it'll use the data store as persistent storage. And that's done all behind the scenes. You don't have to worry about how that actually works. Another thing is it can be used asynchronously, which I guess I could show, but I won't. And I will show one feature, because Guido Van Rossum wrote this, and he told me I had to. And it's called structured properties. So you can see I have an account class, and the second thing I've defined the most important thing, the balance, how much cache you have. But above that, I've said there's a count holder, and the count holder has a structured property, which is a contact. And in this bit of code, I don't have to define exactly what a contact is. That can be another NDB model defined elsewhere, in this case another module, that defines exactly what's in a contact. And that can be reused across different NDB entities. So this is a huge boon for people who are doing complicated data modeling. It means that they don't have to you don't need one entity that defines like 50,000 properties in it, like everything that you would need to have a real bank account. It means you can kind of abstract away content into different modules. Okay, but here's where the important stuff happens. How do you transfer money? So kind of ignore that decorator on the next line, the NDB transactional thing. So here's how our function works. So we're going to take account ID where we're transferring the money from, another account ID that we're transferring to, and an amount. That is probably fairly straightforward. So we're going to actually, given the ID, we're going to look up the two accounts, the from account and the to account, and then we're going to just update the balances. So from account gets the amount deducted from it. To account has the balance added to it. If the from account balance is negative, then you get an insufficient cache exception. Otherwise, both of the entities get saved. So it's actually, now let's look back at the decorator, NDB transactional xg equals true. So what this means, and this is a fairly new feature in App Engine, it means I'm defining a transaction. So when you're calling this function, this is done in a transaction. Either both accounts will be updated with the semantics I defined here, or neither will be, and this is guaranteed. So until recently, you could only guarantee modifications to one entity group in a transaction. Now you can do several. This is a huge win for writing this kind of apps where you have to guarantee that modifications are made to several entities at once. Okay, but I've written this code, but who knows if it actually works or not. So one thing that a lot of people don't take good advantage of in App Engine is we have a really sweet testing framework called Testbed. And it basically allows you to write unit tests, but using the simulated App Engine framework. So you don't have to kind of do complicated mocking. So let me skip over basically all of the imports, the setup, and teardown. This is boilerplate that you can get just by looking at the Testbed documentation. And let's look at this test insufficient cache. So basically, I create and store 2 bank accounts, one for the VC, which has $1 million in it, and one for me, which has $200 in it. And then this next line is kind of interesting. This is a Python 2.7 testing feature. It means the following code, like the code within this width block, I expect it to raise the insufficient cache exception. If it raises that exception, it's working as intended, and if it doesn't raise that exception, it's not working as intended. And then I transfer the money from the VC account to Brian account, but I want $5 million, not $1 million, which is all they have, so it all fails. So this assert raises is new in Python 2.7, but this is like a tiny tip of what's new for testing in 2.7. Python 2.7 actually added over 20 new test methods. They kind of rethought how the framework fits together. There's a lot more places where you can inject your test logic. So I would, if you're using Python 2.7, kind of look at the release notes for it and kind of look at all the new testing things. Like, it's very easy to let testing features slip by unless you're really keeping up. There's a bunch of new other stuff that's added to Python 2.7. So I asked some kind of Python people what they thought was most important. I started by asking myself, and I thought this was the most important thing. The date time delta class gained a total seconds method. I added this myself. I think this will revolutionize Python development. It replaces the one-liner that you had to use before. I asked some other people, some core Python developers. I got this really excited email from Guido. It goes, Python 2.7 advantages, class decorators. Very exciting for him. Alexander Montelli, author, Python luminary, multi-context with was his thing. Brett Cannon, huge contributor, dict and set comprehensions. So what we really learned here is that core Python developers like really esoteric features. But I asked some other real users. This conversation's kind of going on in my Google+. So here's what some people think. There was a big revamp to iter tools, a lot of powerful features there. There's a new the collections library has a lot of new classes in it, like counter and ordered dictionary. You have set literals now, and someone pointed out that the docs are much better than they were for 2.5. Okay, done taking credit time. So next I'm going to talk about some of the limitations we've removed from Python 2.7 versus Python 2.5. So most of them are fairly esoteric, but this is kind of an interesting one. Who here knows the Python timeit module? Oh, good. I actually think that's probably the best Python module, and I looked up who wrote it because I was going to send them flowers or something, but it turned out it was Guido, and I think he's got enough credit for the language already. So it basically allows you to run code many times and generate timings for it. So the code I'm testing is code equals, and then I have this pickled dumps line. So what that's doing is it's taking a Python data structure, serializing it, and writing it into a string IO. And setup, the block above it, defines the setup that's used before that code is run. Then I define a timer, which takes the code in the setup, and I basically run I run this 5,000 times. I do 10 trials, and I take the fastest one. And so I did this, and I ran it in Python 2.5, and I ran it in Python 2.7. And the Python 2.5 output was 3.33, meaning that it took 3.33 seconds to execute this benchmark. And then I ran it again in Python 2.7, which took 0.45 seconds to run this benchmark. So you can see yay! Yeah, be excited. So you can see my previous examples, like when I was doing pill image manipulation, I was using cstring.io, very commonly used Python class. cpickle is a lot less commonly used, at least explicitly, but we use it internally in App Engine for things like memcache, when you're storing data in memcache, and also when you're doing things like if you're using task queue defer, things like that. So even if you don't use pickle directly, you can expect your App Engine apps that kind of indirectly use it, their performance to improve. Most of the rest of the stuff is a bit esoteric, so I'll just kind of skim through it. So we have some, new modules, cpickle and cstring.io. Before in Python 2.5, they were just alias to their slower pure Python versions. We have imp. Please don't use that. It's kind of a dangerous module to use unless you really know what you're doing. Marshall, also fairly esoteric. We support bytecode modification on Python 2.7. So if you want to add gotos to Python, you can do that. Actually, I can't think of a non-esoteric use for bytecode modification either. And finally, we have direct support for compiled Python files. So you don't have to upload your source in Python 2.7. You can just upload the compiled data. Probably you don't want to do that most of the time, but if you have like a vendor who's only providing you compiled code, then you can just use it without needing the source. Or you can just renegotiate with your vendor, which is what I do. Finally, concurrent requests. I like my tagline. It's basically saving you money while making your app faster. So we need a bit of background here. Basically, what concurrent requests do is they reduce the number of instances that your application needs. So an instance is basically a copy of the Python interpreter that's used to handle your requests. So this is from the App Engine admin console. It's showing, I've clicked on the Instances tab, and it's showing me here that I have 7 instances, and it's giving me some data about them. So for many applications, the biggest charge that you're going to get for App Engine is going to be for the instances that you're using. So keeping your instance usage low is potentially a big win. This is just kind of a pro tip. So if you look at if you're in your App Engine dashboard, there's a chart and there's a little pop-up there, and buried in there is an item called instances. Which kind of shows how many, broken down into 6, 12, 24, etc. Time chunks, how many instances you're using, how many you're getting charged for, and how many there are total. So App Engine will sometimes keep some instances around and not charge you for that, just to kind of handle extra load. But you shouldn't count on that. That's just kind of a thing we do if we have spare capacity. And so you can kind of see how your instance charges are changing over time. OK, so let me explain the actual feature. So this is the way requests are handled kind of at a 50,000-foot view without concurrent requests. So let's say you have an application, and you have one instance, so one copy of Python that's not currently handling a request. So a request will come in for your application, and App Engine will go, oh, I have a free instance, and it'll forward the request to the instance. It's probably what you expected would happen. So if you get another request that comes in, and that one instance, which is the only instance you have in this example, is already busy handling the first request, then App Engine has to create a second instance, wait till that's created, and then forward that request there. So to handle, if you have 2 concurrent requests, it basically means you need 2 instances to handle them. So kind of looking at the math very simply, if you have 10 requests per second, like every second you're getting 10 requests, and each request takes 1 second, then you need 10 instances to handle the load, if I did the math right, which I think I did. So with concurrent requests, it changes a bit. So your app receives a request, and the request is forwarded to the instance. And if you get another request, the request is forwarded to the same instance, which then creates a thread and handles the request in that thread. So this means we're now serving, in this diagram, we're serving twice the traffic with we're serving the same traffic, but with half the instances. So the obvious question here is, will this make my application slower? Because I have the same CPU resources for one instance, but I'm now sending 2 requests for it instead of 1. And the answer, of course, is yes. This will make the request handling slower. I'm trying not to look at the App Engine people who might be glaring at me now. But the slowdown is probably much smaller than you expect. And I'll for basically the rest of the talk, I'll walk through an example where I load test a real application, and by real I mean my Predator application, and see how it behaves. So here's a reminder of basically what the Google Plus variation of the Predator application does. I remove some of the exception handling because cool people don't do exception handling, and it makes the code too big. And I've put comments that kind of break the code out into 3 stages. So first, we load the Google Plus profile. And basically, when we are loading the Google Plus profile, we're not using the CPU. We're just kind of waiting for network to get back to us with some data. Then we load the image, the profile image. And once again, we're just waiting for I/O there. And finally, we use a ton of CPU to decode the JPEG, convert to grayscale, do a palette substitution, and then recompress as PNG. So if you kind of look at this over time, like I did timing, and of course these timings lined up perfectly on 100 millisecond boundaries. It always takes exactly 100 milliseconds to load the profile. It takes 300 milliseconds to load the image, and then it takes 100 milliseconds exactly every single time to transform the image. Okay, I totally made these numbers up. No, I didn't make them up, but they're obviously approximations based on many runs, and I've rounded to the nearest 100 milliseconds. Now, if we look at kind of this program flow versus CPU usage, we can see we start by basically using no CPU. We're just waiting for a URL to be downloaded from the internet. And that continues the same for when we're loading the profile image. We're just waiting for the image to come back from the network. And finally, we have a big chunk of CPU usage while we're transforming the image. So in this particular case, we can see that we're spending basically 1/5 of our request time using the CPU, and the rest is idle. So without concurrent requests, that CPU time is basically wasted. There's just nothing for the CPU to do while it's doing this downloading. So that's the theory. Now let's load test it. So I don't want to actually do URL fetching in my load test because the performance is too variable. Downloading stuff from the internet takes a variable amount of time. So I've cleverly replaced the downloading with sleep statements. So I sleep 100 milliseconds to simulate the loading the Google Plus profile, and another 300 milliseconds to simulate loading the image. And I just I put a picture of a rock in the application directory, and that's the one I transform. So I upload this application, and then I use a tool called JMeter. So has anyone used JMeter? Oh, wow, lots of people. So JMeter is basically a load testing tool. And basically what it does is you tell it, create a number of fake clients that hit a particular URL, and it simulates hitting that URL, and as soon as it's loading, hit refresh, wait till it loads again, and keep hitting refresh. It's basically simulating a person who keeps hitting refresh. And in this particular example, I'm simulating 25 people hitting refresh continuously on my Predator application. So at the top, I've kind of copied out the data that I got here. So in this case, it's collected, it's done 790 requests. So it's giving it a throughput of 1,500 requests per minute. And the average and median numbers you see on the right are latency. So the average request is taking 950 milliseconds to be responded to. So I actually did this load test, and I kind of compiled a table with my my results. So if you look at the top row, so this is just the default configuration for App Engine uses what's called F1 instances. There are 600 megahertz virtual CPUs. And I generated the timings for that without concurrent requests enabled. So the latency that I measured was basically 1 second, so 1,015 milliseconds. It created 24 instances to handle this load. And I just normalized the dollar cost to, to handle this load, let's say it costs $1. Now, in the next line, what I've done is I've done the same load test, but turning concurrent requests on. So you can see that latency actually increased by 30%. Kind of sucks. But the number of instances required to handle this traffic went from 24 to 9, which is a big reduction. So, and finally, the normalized dollar cost is 38 cents. So our latency increased by 30%, but our cost was reduced by 60%. So this might be a trade-off you're willing to make. You might be saying, well, to pay 60% less money, I'm willing to make my users wait 30% longer. But if you don't like that trade-off, you can bump up the instance class from an F1 to an F2. So an F2 is basically twice as fast as an F1. So we get slightly different latency numbers. We're now, instead of being 30% faster, we're a bit less than, 30% slower with concurrent requests on. We're about 10% slower, a bit less than 10%. We're using 8 instances instead of 9, and our normalized dollar cost is 60-something cents. So this is also a possible trade-off that you'd make. Latency's only gone up a bit, but you're still saving 30% of the cache. And then I did a final increase in the, I jumped from an F2 to an F4 and reran the benchmark. So in this particular case, latency actually fell from 1 second to 0.9 seconds about. The number of instances went to 6, and due to a coincidence of math, the normalized dollar cost is the same. So you have a fourth of the instances, but each of them is 4 times more expensive. So you end up with the same dollar cost. So you can kind of see like concurrent requests in this scenario are a win on basically every level. If you turn them on and switch to an F4 instance, you would get reduced latency, so a better user experience at the same cost. Or you could choose to give the user a slightly degraded user experience from a latency point of view and save yourself some money. And I will point out that this workload is actually pretty bad from App Engine's point of view. If you think about what these requests are doing, they're basically idling the CPU, and then they're doing a huge CPU spike. So that's a very tough workload for a scheduler to deal with, because it's like, oh, this instance, it's doing nothing. I can start packing on requests, and then suddenly there's a huge CPU spike that actually lasts for quite a long time. So there are other workloads that have a more even mix of CPU and I/O. And by I/O, I don't mean just URL fetch. I mean like data store, memcache, anything where the CPU is not used will generate better, kind of a better trade-off than the one you see here. Okay, so I've clearly convinced you that concurrent requests are awesome and that you should use them. So how do you actually do it? So the first thing you have to do is make sure that your code is actually thread safe. And thread safety is like this huge thing that I don't want to spend too much time talking about. But basically, the easiest way to get yourself into trouble and make your code not thread safe is to basically change global variables without using some sort of lock. So has anyone figured out what the problem with this code is yet? So I've cleverly decided to add a cache of the images I've already transformed before. So basically what I'm going to do is when a URL comes in, I'm going to generate the predator image, and then I'm going to save it in this cache. So if the URL is already in the cache, which you can see right, the second line in the get handler, then I'm going to just output the cached version. Otherwise, I'm going to compute the image as normal. In the end, I don't want the cache to grow forever, so if there's greater than 10 items in it, I'm just going to randomly throw an item away, and then I'm going to store the the image I just generated in the cache. So the disaster here is I can check to see if the image is in the cache while a concurrent request runs along and it removes that item from the cache. And then when I get to the next line where actually I'm writing the cached item, then I blow up because the value is not there. So this isn't kind of a comprehensive examination of thread safety, but this is the kind of pattern that will screw people up, where they're mutating a global variable without having some sort of lock. But I'm sure it'll be easy for you to fix that if you have problems like this. So just do that, and then go to step number 2. So step number 2 is you need to define a WSGI application object. Probably existing App Engine apps will pretty much already be doing that. In all my examples, I've been defining a Web App 2 WSGI application, but you can use any WSGI application you want: Django, Bottle, Flask. WSGI is like the dominant web standard or web application standard for Python, so you're going to have no problems using alternatives if you want. Then you basically take your app.yaml file and you take the name of your module, put it in the script field, put a period, and then the application name, and you're done. Surprisingly, this is not the easiest step. This is the easiest step. You just take that thread safe false I showed you before, set it to true, and you have concurrent requests enabled, and you're all done. Speaking of all done, I'm all done, except for just let me summarize what we've talked about. So with Python 2.7 runtime, you get a much nicer third-party library experience. We support a bunch of libraries that people have been really asking for, and we support it in a way that's basically future-proof, where we have an upgrade path for them. There's some Python 2.7 features that are really useful for web application development, and there's some other features that are really esoteric, but core Python developers seem to like them. We have fewer limitations in the runtime, and finally, we support concurrent requests, which have the potential to save you some serious money and or make your apps faster for your users. So thanks for coming. Thanks for Wikipedia for the dinosaur pictures. Thanks to the Python community for making Python. We couldn't really do App Engine without it. And thanks for all you App Engine people for making cool apps.
Questions?
Absolutely. Could you go up to the mics just so this is recorded?
So I have a question, and is do you plan, or is there any plan to support additional runtimes, namely PyPy?
That's a great question that I won't answer. We're thinking about new runtimes all the time, but we can't really talk about what whether we're actually going to support them or not. Sorry about that. You can bug our product management folks. For example, there's one right there, and try and beat some sort of answer out of him if you want.
A second quick question.
Yeah.
Can you use doc tests with the unit test framework?
I haven't tried it, but I can't see why that wouldn't work.
Okay, thank you.
No worries. Maybe alternate mics.
So you talked about concurrent requests. One of the common requirement was to reduce the cost by having concurrent requests.
Yes.
The other most important thing is the functionality that comes with concurrent requests, especially with stateful applications. So earlier, you never had to go to the same server. It always goes to a different server.
Yeah.
But if you have to have a server with a data already in memory, and you have to go back to the same server, that's not possible with App Engine. Now with concurrent requests, that's possible, but then it's not possible with App Engine.
So it's not possible in the model you're thinking about. So like App Engine will send concurrent requests to one instance, but it won't do that forever. So say you have, for example, 1 million concurrent requests. It's not going to send 1 million requests at one Python interpreter. It'll start ramping up new ones as the instances get saturated. So you won't have shared memory potentially across those shared requests. Now we have another thing called servers. I don't know if you've looked into that. Sorry?
You mean backends or?
Sorry, backends. Sorry, my mistake. Backends, and they basically allow you to have like some fixed number of backends with potentially a large amount of memory to deal with this kind of thing.
Okay.
But actually, maybe you could come by the booth afterwards and we could talk
Okay.
about this. I'm curious what your use case is. So could you wait a sec, Robert, or we'll switch slides?
Hello. Hey, I have a question. In your code, you show that you were using the web app to HTTP request handler.
Yeah.
In order to use concurrent requests, you need to use those handlers?
Absolutely not. You can use any thread-safe WSGI application framework. So you can use Web App 2, Django, Bottle, Pill, whatever.
And a side question to that is just
Yeah.
In the Web App 2, you define a get method. Do those methods map to the request type? Like,
Oh
is it
yeah,
a
exactly.
post,
Yeah,
put,
sorry, they do.
etc.?
So if you want to handle GET requests, you define a method called GET. If you want to handle POST, you define a method called POST, push for push, et cetera, et cetera.
Okay, so it's like a magical route kind of thing? Like,
Yeah, but if there's a framework that you're more comfortable with, just use it.
okay.
Not that Web App 2 is bad or anything, but
So how does the saturation of an instance, how is that determined? Is that, what I'm specifically wondering is if you have requests that are really variable with their latency. So in your benchmark example, they were all uniform latency per request. But if that's highly variable, say you have some that are a couple hundred milliseconds, some that are over a second, how is that going to play into threading?
So it's hard to give you an answer that's not going to get dated because we want to be able to make schedule improvements without committing ourselves to a particular implementation strategy. But right now we're basically sampling the CPU usage like back by I think a couple hundred milliseconds, and we're using that to judge whether the whether the instance can handle more requests. So this is kind of why this is pathological, because it doesn't really have a long-term history of how requests have behaved over time.
I see.
Was that sufficiently precise, or?
Yes. Yeah. I think that,
Okay.
that makes sense. That's what I was wondering about.
Yeah. Thanks.
You mentioned the new NDB module, and you talked about a new property type there.
Yeah.
What were the differences between that and a reference property?
So
short.
a reference property creates two separate entities. So it's basically you have two separate entities in data store, and a reference property joins them up. What a structured property does is basically it puts them into the same logical entity, but it's an organizational thing, not kind of a data store level thing. So it helps you with data modeling, but it doesn't actually change the kind of entity abstraction. I felt I explained that really poorly. Feel free to ask a question that gets me to clarify what I meant there.
No, that's clear enough. Thank you.
Okay, thank you.
So structured properties and indexing, what's the impact on the number of data store writes per,
It essentially doesn't change anything. So if you have a indexed structured property, let me phrase it another way. Whether a property appears as a structured property or in like the top level of a model, it has the same cost from an indexing point of view. You have another question?
but is it going to create an index for each property within this property, within the structure?
If the properties within the structured property are defined to be indexed, then it will create an index for each of those fields. So basically, if you imagine a structured property, like you have a model and you have a group of code that's logically combinable, like an address, and you want to have like a line 1, line 2, zip code, whatever. If you extract that out and put it in a structured property, it doesn't change the indexing behavior at all. I hope that helped. Sorry, structured property. Structured property. Did I say reference property? Well, no, because now you just haven't, sorry, the question was, does reference property change the indexing characteristics? And the answer is, with reference property, you have another data store entity that represents the other set of data, and that other entity will still get indexed. So no, no, it won't change the indexing characteristics. Sorry.
So it might be a while since I looked at this, but with, is it possible now with a third-party library to have one that connects to an external service using a custom TCP protocol?
No, it's not.
And is it ever going to be possible?
Ever going to be possible is such a hard question to
Or is there any
answer.
plans to make that possible?
Oh, it is on the roadmap. So
Awesome.
yes.
Thank you.
Sorry, I didn't know if it was public or not. My mistake. Thanks for the question. It allowed us to highlight a new feature or an upcoming feature. Yeah, sorry.
I understand that we have to pay for bandwidth when we're talking between app engine instances. Is that going to be free at some point?
I have no information on pricing changes there, but I suspect not, because a PM is nodding his head. But once again, he is available for your haranguement or other entertainment if you want to have a go at him. Anything else, or should I start giving away stuff?
Well,
Okay.
I want you to start giving away stuff, but are you still working on startup time at all to reduce that a little bit? Or?
I am personally not working on startup time. I'm trying to think if anyone's doing anything to reduce startup time right now. I don't think so, actually. But feel free to talk to me if you're hitting some case where startup time is slow.
Okay.
Cool. Thanks. Wait, you want me to throw them? Oh, really? No. I like the throw into the crowd strategy. It seems so unsafe. Well, if you have some sort of death threat, then can you go stand with that group and take your chances? Oh, sorry, it wasn't fair. Okay. We're out. Sorry, guys.